So today we want to talk about solving logarithmic equations. It's very similar to what we did with exponentials the other day. So we just go through 3 steps here. First is we isolate the log. If there are multiple logs, we may need to condense them, right, to get a single logarithm. So you might have to move things from side to side even. Just use your algebra rules. Next thing, once we have that single log equals something, so the log with a base of something equals something, then we're going to write it in exponential form. If you're good at switching it, that's great. Or what we can do is raise the base to each side of the equation. It's called exponentiating, which I think is a great word. I'll show you how that looks. That's nice if you're not great on switching forms. If you're a little shaky, this is the way you want to do it. And lastly, we solve and check. We will see extraneous solutions because logarithms have a restricted domain. You know, so you can't take the log of 0. You can't take the log of a negative. So those are things we have to look at or be aware of. Our first example here, we have 4 plus 3 log of 2x equals 16. So we see that we have a logarithm with no base listed, so we know it's a common log, right? It's base 10. So with this, we have a 3 being multiplied by the log, and then we have 4 plus this term. So to isolate the log, first we're going to deal with the 4. We'll subtract 4 from each side. And this is just old, like working a 2-step equation when you're back in Algebra 1, right? Except we're not solving for x, we're solving for the log of 2x, common log of 2x. So we'll divide by 3. So the common log of 2x equals 4. So now at this point, we can switch forms, correct? So the base is 10. The exponent over here is 4. So we can say that 10 to the 4th power equals 2x. 10 to the 4th power is 10,000 equals 2x. So then x will equal 5,000 is our solution. Didn't even need a calculator there. So from here, I'm going to go back and check it. I'm just going to type this line in. I could either store 5,000 as x in my calculator, or I could just say 2 times 5,000 would work fine either way. So if we go ahead and do that, we will see 4 plus 3, common log of 2 times 5,000 gives us 16. So that checks. So we'll go ahead and that should be our solution there. The one thing I mentioned on the second step here is if you're not feeling great about switching forms here. Okay, now what we can do is kind of it's an extra step, but it might really help you in terms of switching forms, is if we have this and we know we want to get it in exponential form, what we can do is, we know this log is a common log. It has a base of 10. So what we can do is we can exponentiate both sides, meaning I can make each side be an exponent of the same base. So we could write it as 10 to the common log of 2x equals 10 to the 4th power. Right? They both have the same base. But we know that if you have 10 raised to a common log, this was one of our properties, correct? Is that those would cancel. The property being if you have b to the log base b of x, it just gives you x. So this would just give us 2x equals 10,000. So, you know, it's just a different way of thinking about it. But that might be something, if you tend to make mistakes switching forms, that might be something that's really helpful for you. Okay, for our second example here, we have the natural log of 2 plus x equals 1. So we have a natural log we're starting with. That means if we choose, you could just switch forms and write e to the first equals 2 plus x. A lot of you, that makes perfect sense. Maybe we'll try this raise each side to a power idea to help us transform it a little bit. Right? I knew I wanted to choose e as my base because e and natural log are reciprocals and they'll undo each other. So here we're going to get 2 plus x equals e to the first. Remember, e to the first is just a number, right? That's all it is. So here our exact answer would be e minus 2 is what's equal to x. But we were asked to round to 3 or 4 decimal places. So I'm going to do e minus 2. Whoops. E minus 2. And that gives us that x is approximately 0.7183. Again, I could store that in my calculator. So again, once I had this, I hit store, and then the x, t, theta, n button, and then enter, and then once it had stored it, I just typed in the natural log of 2 plus x to make sure that it gave me the answer 1. So let's see, natural log of 2 plus x, and it gives me 1, right? So a great way to check there. As soon as you get your answer, store it, plug it back in. Then you won't even have to like mess around with the variables and stuff. It'll just seem to work here. So the next one I want to look at's got a little bit more going on here. This third example is we have 2 times the common log of x equals the common log of 2 plus the common log of 3x minus 4. So with this one, well, we haven't had to do this yet, but obviously there's a whole bunch of logarithms here, correct? Like we need to either, a couple options, we could either isolate them and get them all on the same side, or we could just get a log equals a log, would also be okay. Now, what you'd want to do to help with this is we'd want to, I guess we got a bunch of options here, but let's maybe look at it as, let's just see if we can get a log base 10 equals a single log base 10, then we can maybe exponentiate to get rid of them that way. So I'm going to write this left-hand side as the common log of x squared, right? Because I want to get that number from the front up as an exponent. Then here, these two logs are added together, correct? So since that's the case, I can write the log of 2 times 3x minus 4. Again, just multiply those together. We're going to have to distribute that. That's a thing, right? That's going to happen. So what I can do here is, at this point, since we have one logarithm equals one logarithm, and they're both the same base, if they're equal, we know their arguments have to be equal as well. So here we can say x squared equals 2, 3x minus 4. Does that follow for everybody? Or you could have thought of it even as, if you make each of these be a power of 10, right? They would cancel out with the logarithms if you want to think of it that way. And then from here, we get x squared equals 6x minus 8. Well, here we have an x squared and an x, so we're dealing with a quadratic. Okay, so let's put it on one side. It should be factorable. So we get x squared minus 6x plus 8 equals 0. We factor this. X minus 4, x minus 2 equals 0. We can set each factor equal to 0 and solve. And this gives us x equals 4, or x equals 2. Now, we have to check this. If one of them would have been negative, we know that we can throw it away right away because it wouldn't have worked over here. Right? But we want to take a minute with our calculator. You can check them a little bit to see if they fail right away, but we should still check to see if the answer's right. See, if I put 2 in here, I get 6 minus 4, which is still positive 2. Yeah. So here, to check this, when we do check, we're going to go all the way back to the original, correct? So put 4 in for x over here on the left side. And I'm going to go ahead and just show it by hand, but you could totally use a calculator too. It works fine. But so if we have 2 log of 4, is that equal to the log of 2 plus the log of 3 times 4 minus 4? Is kind of the question here. So that's just the common log of 16, right? When you bring the 2 inside there, square it. This will be the common log of 2 plus the common log of 12 minus 4 is 8. Well, if you put these two logs together, you get common log of 16. So that works. So that checks, so that solution works. For 2, you would get 2 common log of 2 is common log of 2 plus common log of 3 times 2 minus 4. That would be 8, wait, that's 6 minus 2. So we get here would be the common log of 4. I like to put a question mark over the equal sign, just to remind myself that it might not be true because I'm checking it. And then here we get the log of 2 plus 6 minus 2, or 6 minus 4 is 2 also, plus log of 2. So we get log of 4 equals log of 4. So that checks also. Okay. The way, if you do the math correctly, which I'm sure we will, the way they tend to fail with extraneous is you're going to end up getting a negative or a 0 inside a logarithm. Because this check, if you didn't know that was a problem, you still might think it was okay. But you know, if you ever get log of -8, it fails. Like, we can't have that. It just won't work. Now, I don't have any idea what these numbers are. If you just type the numbers into the original equation in your calculator, it would give you some decimals, but the decimal created with both sides should match. That's how that works. All right. Okay, our last example here, log base 3 of 3x plus 9 equals 4. So kind of a nice when it's already isolated. That makes things a lot easier. Here we have a base 3, so we can just go ahead and switch forms. It would be 3 to the 4th power equals 3x plus 9, or I'm going to write it as 3x plus 9 equals 3 to the 4th power because I like to have x on the left. It doesn't matter how you do that. So at this point now, 3 to the 4th, we know that's just 81. So 3x plus 9 equals 81. Okay, now we're just solving a two-step linear equation. Right? This is like the Wayback Machine here. Subtract 9 from each side. You get 3x equals 72. Okay, divide both sides by 3, and we get 24. Okay, now to check that, probably just run through it here. 3 times 24 we know is 72. 72 plus 9 we know is 81. Log base 3 of 81 we know is 4. That's our answer. So, should be pretty, you know, that one's pretty nice. You don't have to move stuff around.